We are graphing reciprocal functions today. And to get started, I want you to graph these on your calculator so you can see what they are. Plus, it's good to know how to graph them on your calculators. Okay, so to graph reciprocal functions, they are obviously reciprocals, which is 1 over whatever. So if we want to graph cosecant of x, we actually have to graph 1 divided by the sine of x. So that would be the reciprocal. And so what I want you to do is in your calculator, in y1, let's go ahead and graph the sine of x. And then in y2, we're going to go ahead and graph 1 over the sine of x. If you want to do the alpha f1 thing, you could do that. So you do 1 over the sine of x. And that is the only way that we can graph cosecant. Okay, now, anytime you're doing a trig function, you want to do a trig graph. So do a zoom trig. What is that? Zoom trig. So you go to zoom, and you find the one that says zoom trig. Whoops-a-daisy. Zoom trig. Oh, thanks. Oh, okay. Great. Beautiful. So you can see here, in blue, we have graphed our regular old sine function starting at 0. Got our sine song, middle, high, middle, low, middle. And in red, that is our cosecant. That is our cosecant function, which is kind of interesting. You can see what's going on between the red that's going up here towards positive infinity, and then it flips and this is like way down, pointing downward. What do you suppose is in between those things? An asymptote, yeah. Because right here, sine has a value of 0. The y value is 0. And what happens when you do 1 divided by 0? It's undefined. And so that creates a vertical asymptote. And so everywhere that sine passes through the midline, the middle of that function, we get a vertical asymptote. What's really nice about this is you guys already know how to graph sine and cosine. And you can see, if I know sine and cosine, then I can simply put in some vertical asymptotes, and the max matches up, and you just sort of make these little parabolas. It flips out, and that's the reciprocal part, all right? Everything just flips over, and so that's what it does. It's kind of interesting. So let's look at, in y1, let's go ahead and do cosine of x. And in y2, we want to do the reciprocal, which would be 1 over cosine of x. What is the reciprocal of cosine? Secant. Yeah, secant. Yeah. So let's go back to y equals. We're going to type in cosine of x, and then 1 over. Oh my goodness. Cosine of x. And then again, you can do zoom trig, sorry. Oh, crap. Wait, say what now?
It just doesn't work if you put like secant.
We don't have the button. There's no secant or cosecant button, yeah. And so we want to do again a zoom trig. Anytime you're graphing in trig, zoom trig is the way to go, which is zoom 7. And so now, again, we see our blue function here is our cosine curve, which you can see if it starts here at 0, 1, high, middle, low, middle, high. And again, our secant function, very much. It's just sort of, we get these vertical asymptotes again. Anywhere cosine crosses the middle, the midline, we get that vertical asymptote, and then these just up and down U's, okay? So it's really very easy to graph these functions. And that's pretty much how we're going to graph them. We're going to graph the parent, all right, the main one, and then we're going to draw in our vertical asymptotes and do the little flips, okay? Now, let's look at, let's see, cotangent. So in y1 we have tangent of x, and y2, the reciprocal is 1 over tangent of x, and that would give us cotangent. That's the only one that actually makes sense. Yeah, that's an inverse function. Very, very different. Yeah, very, very different. So 1 divided by the tangent of x. Yeah, it is not the inverse function, okay? All right. Now this one is interesting. It does a little bit different. So tangent, we know, is an increasing function, toes to nose. Cotangent here is in red, and you'll notice though it didn't just reflect. Cotangent slid over, didn't it? So cotangent has vertical asymptotes at 0 and pi. It's actually shifted a little bit, okay? And so cotangent, you might want to draw a little sketch on your sheet here to remind you, just kidding. It has vertical asymptotes here at x equals 0 and at x equals pi, and at pi over 2 is where it hits the axis, right in between. And it's a decreasing function. I think about it as putting on your coat. You wrap it over your shoulders first, and then it sort of goes down to your toes. Like, I don't know why, but putting on a coat so it starts high and goes low. Does that make sense to you? Like, do you see what I'm thinking in my head? My brain is weird, but I heard that from another teacher, and it just stuck with me. So the period on tangent and cotangent is how long? What is our period for tangent and cotangent? Pi, yeah. So cotangent has our vertical asymptotes at 0 and pi, every pi, 1 pi, 2 pi, 3 pi, 4 pi. What is the period for all of the other functions here? Yeah, 2 pi. And just like before, so we're basically doing the same thing. And in Delta Math, it turns out to be a pretty easy thing to do as well. Just like you were graphing tangent functions with shifts, we're going to do cosecant and cotangent with shifts as well, yeah.
On my calculator, like the other tangent, it won't cross the 0 line? Is that normal?
Correct. So yours is just, hi. Oh, okay. There you go. Thank you. All right. Yours is just the size of the pixel that's causing a thing, but I'll have to look at the settings on that. All right. So we are going to be graphing these changes, the vertical stretch. We're going to do using Delta Math. So they have the little dots on these, so you can do the little vertical stretch in Delta Math. So we're actually just going to worry about our sort of parent function here, the period change, okay? So to get started on this one, I'm going to go ahead and get rid of that -3. So this first one here, f of x equals 3 over 2 cosecant of x. In Delta Math, it's going to ask two things. It wants to know the period and the equation of the first asymptote. So we can figure out our normal period by doing 2 pi over b. 2 pi over b. What's our b value here? Yeah, there's a little invisible 1 right there. So 2 pi over 1 is just 2 pi. So this curve is going to start at 0 and end at 2 pi. And what I'm going to do is I am just going to graph my reciprocal function. I'm going to graph my sine function and then flip it out. Does that kind of make sense to you? So this sine function, let's see, it starts at 0 and ends at 2 pi. What's right in the middle? Pi, okay. And then I can go ahead and just do the other two midpoints there, and I don't need to mark them, just put the little tick marks there. Now, this is my sine function, and it has an amplitude of 3/2, so what's my maximum?
3/2.
Yeah, so on delta math, you'll actually get a dot that you'll be able to make it grow, okay? So you'll be able to stretch it. This is my problem. Doing this on paper versus doing it in delta math is a little bit weird. So I'm going to do just a dotted sine function, so middle, high, middle, low, middle, and this is just what I like to just call our sort of guideline here. That's our sine curve, and if we want to then graph cosecant, all I have to do is flip everything out. I'm going to draw in my asymptotes, so anywhere we cross the midline is going to be a vertical asymptote. So there's a vertical asymptote here at x equals 0. Where's another vertical asymptote? At pi. So x equals pi. And then again we hit the midline here, so that is also going to be x equals 2 pi. There's another vertical asymptote. And then we just get these U shapes. So we get right here is our maximum. That turns into an upward facing U. And then our minimum turns into a downward facing U. It just flips out, and that's all it does. Okay? So that's the cosecant function there in pink. So it's just based on exactly what you already know how to do. Now, they're all going to look like 2, 3, and 4 here, so you'll notice I had to do some changes. So I'm going to do my best, you guys, to... What's the equation of one asymptote on this first one? Like x equals 0? Yeah. And then it asks for what shape is it immediately after that vertical asymptote, and so you would pick the upward facing U one. Okay? So it's kind of weird. I'll show you a delta math one too, but here we go. Number 2 is 2 times the secant of pi over 2x, and then a plus 1. What does this plus 1 do? Yeah. And what does the 2 do? Yeah, it's an amplitude. It's a vertical stretch. All right. And this one goes up 1. Okay. So first, I'm going to graph its reciprocal friend, which is cosine pi over 2x. And again, we want to figure out the period of that basic graph. The period's going to be 2 pi over what? Pi over 2. So the b value is pi over 2. So we're dividing by that. And I don't like to do that. What do we do instead?
By 2 divided by pi.
2 over pi. Multiply by the reciprocal. Good. And it's 4. Why is it 4? Yeah, the pi's cancel out. Good, good, good. All right, so we have a period of 4. All right. So just like before, we're going to draw our vertical asymptote. Where's our midline? It gets shifted up 1, right? Does that make sense to you? We're up 1? Okay. So I'm going to put, just like before, a little 1 right there. And this is our sort of horizontal axis on it. All right. And from 1, what is our maximum going to be? 3. And what's our minimum going to be? -1. -1. Okay, good. Okay, good.
How is our maximum?
Because it has a vertical stretch of 2. So if we're starting here at 1, it's going adding 2 for the amplitude and subtracting 2. Yeah? Okay. Now, our period is 4, which means it starts at 0 and ends at 4. And what's halfway? 2. And between that?
3.
Yeah, 1 and 3. Now, we are graphing the cosine curve. And again, I'm just doing a little dotted cosine curve. And what's our cosine song? High, middle, low, middle, high. Okay, so here is our lovely little cosine curve. All right, now, to graph secant, we draw in our asymptotes. So anywhere we cross the midline, which is right here on 1, we go out asymptotes. So where is one of our asymptotes? At 1, yeah, right here is x equals 1. And where's another vertical asymptote? At 3, good. So you draw in your asymptotes. And then, yeah, so then we have, at the maximum, we get an upward-facing parabola shape. And at the minimum, we get a downward parabola. Okay. Good so far? Yeah. All right, let's try just one more here, I think. One more, and then I'll do one on delta mass so you can see it. Good. I'm glad you feel that way, because it is a slightly different in delta mass because they're actually going to stretch and slide, okay? So it's either easier because all you have to do is this part, okay? Secant, the reciprocal is cosine. So I'm just going to start with my little vertical axis here. What's my midline? Yeah, so that was the up 3 part. And the amplitude, vertical stretch by 2. What's our maximum going to become? 5. And our minimum? 1. Okay, adding 2 and subtracting 2, yeah? Okay. All right, and then we can have our little midline here. And I need to know my period. So how do we find the period? 2 pi over? 4/3. All right, and I don't like to divide, so that's going to become 2 pi times 3/4, which is 3/2 pi. 3/2 pi. 3 pi over 2. Oh, goodness. So we start here at 0, and we're ending at 3/2 pi. What is halfway? Yeah. Halfway between 0 and, so 3/2 pi, sorry. That's just 3/2 pi times 1/2 becomes 3/4 pi. Good. All right, and then we have our little half marks between those. And we're graphing cosine, so the cosine song is high, middle, low, middle, high. Okay, and so then we can do our little cosine curve. All right, and where are the asymptotes? Yeah, where we cross the midline. What is this value? 3/8 pi. Very good. Yes. Very good. Halfway between 3/4 pi and 0, so half of that. This is 3/8 pi, 6/8 pi, 3/6, 9/8 pi. Crazy, yeah, but there's the other one. All right. Then the maximum becomes an upward U, the minimum is a downward U, and the maximum. Okay? And then, I didn't graph tangent and cotangent. I think that cotangent's probably okay, actually. I'll do some on delta mass. So I'm going to show you some on delta mass.